All right. Everyone's job here is to yell if I look like I'm going to step this way or this way, okay? Because I'm standing on a box because I'm very short. So I'm really a little worried about this, but at the same time, I want to be able to see you all, and I want you to be able to see my face. So this is Reacting for Empathy. I'm Jana Beck. I'm super stoked to be back at my third React rally. I love this conference. This slide deck is online if you haven't already seen links in various places. There is a bit of code. I think it's going to be big enough, but I know it's really tough in the back. So if you want to load it in a tab and follow along, yeah, that may be nice for you. I'm J.E. Beck on GitHub and in most of the Slack teams that I'm on. So you can hit me up in this Slack or other ones if you see me there. And I'm iPancreas on Twitter. I'm a data visualization engineer at Stitch Fix, but I'm not actually here to talk about data visualization today or anything work-related. I'll be talking about a side project of mine. I work in the algorithm side of Stitch Fix, which is the data science group. And I will say if you want to know about what kinds of things we do, there's a link here to a really cool animated tour of data science at Stitch Fix. Before I really dive into the project that I'm going to tell you about, first I'm going to tell you a little bit of a weird story, so bear with me on that. This is a treadmill. I think all of you probably recognize it, but I suspect that many of you maybe don't know for what purpose treadmills were originally invented. This is an etching from an 1817 newspaper in London depicting one of the first treadmills, which was at Brixton Prison. And this is the guy that invented it. His name is William Cubitt, and he was inspired by seeing prisoners that were idle, and he wanted to help them develop the habits of industry, as he called it, by making this machine, the treadmill, which that's what it looks like again. It looks a little bit more like a modern Stairmaster than today's treadmills. So he was inspired to do this because, well, it fit into the Victorian thinking at the time that really promoted atonement through hard work. And they actually loved the fact that in the prisons where they installed these at first, they didn't even have them hooked up to anything. The prisoners were grinding air, as they called it. And that, to the Victorians, was a more pure form of punishment, the fact that it wasn't even doing anything. And sometimes these things were super awful. This is an actual picture of one of these treadmills at, it's in the notes somewhere, I can't remember what prison. And so they put these slots between the prisoners at this one so that they were all completely isolated from each other, zero fun allowed. And prisoners that were sentenced to hard labor, they served their sentences on treadmills for this era of British history. And they typically were on a treadmill for about 6 hours a day, if that's what they were doing, which was the estimated equivalent of about 10 to 14,000 feet of elevation gain. So to give you a little context, this is Ben Lomond Peak in the Wasatch Range. It's about an hour north of here, and it's pictured from my dad's deck because he lives up there. And we've hiked it to the summit twice, and it's about 6 hours of pretty strenuous hiking, 13-mile round trip, and it's only about a 4,000-foot elevation gain. So imagine doing more than that every day and not having nice mountain views and fresh air, and on the other hand, having a prison warden watching your every step, literally. And then today, now we have treadmills, and we actually pay money to use them. And then finally, as the final step in this evolution, we have this, right, which speaks for itself. So the inventor is dead, literally in this case, right? And the whole point here that I want you to file away in the back of your mind while we talk about the project I'm going to tell you about today is that technologies have histories and contexts, but those contexts are not definitive. So yeah, this isn't a talk about treadmills. It's a talk about a project that I have done in my spare time in the last few months. And this project starts with a man. His name was Jean-Dominique Bauby. Sorry, one more. And he was the editor-in-chief of Elle magazine. He's French. And unfortunately, on December 8th, 1995, he suffered a massive brain hemorrhage. And he ended up completely paralyzed. Basically, he could wiggle his head a tiny bit, and he could blink with his left eye. His right eye had to be sewn shut because it wasn't closing properly, so then it was very irritated. And in his memoirs, he described his condition. So he said, "You survive, but you survive with what is so aptly known as locked-in syndrome. Paralyzed from head to toe, the patient, his mind intact, is imprisoned inside his own body, unable to speak or move. By blinking, in my case, blinking my left eyelid is my only means of communication." So by blinking his left eye many, many times, Bowlby dictated his memoirs, and these were published as The Diving Bell and the Butterfly. Unfortunately, he died of pneumonia pretty suddenly and tragically only 2 days after the memoirs were published in March of 1997. So the technique that enabled him to dictate memoirs just by blinking an eyelid is called partner-assisted scanning. And he described this in his memoirs too. And since he put so much effort into these memoirs, I think it's great to like read what he actually wrote. So he said, "It's a simple enough system. You read off the alphabet, ESA version, not ABC, until with a blink of my eye, I stop you at the letter to be noted. The maneuver is repeated for the letters that follow, so that fairly soon you have a whole word and then fragments of more or less intelligible sentences. That, at least, is the theory. The jumbled appearance of my chorus line stems not from chance, but from cunning calculation. More than an alphabet, it is a hit parade in which each letter is placed according to the frequency of use in the French language." And he described even more details about what this was like to communicate in this method with lots of different people, because his speech therapist first got him working with this system, but then he would use it with all sorts of people who came to visit him in the hospital. "Nervous visitors," he said, "come most quickly to grief. They reel off the alphabet tonelessly at top speed, jotting down letters almost at random, and then, seeing the meaningless result, exclaim, 'I'm an idiot.' But in the final analysis, their anxiety gives me a chance to rest, for they take charge of the whole conversation, providing both questions and answers, and I am spared the task of holding up my end. Reticent people are much more difficult. If I ask them, 'How are you?' they answer, 'Fine,' immediately putting the ball back in my court. With some, the alphabet becomes an artillery barrage, and I need to have 2 or 3 questions ready in advance in order not to be swamped. Meticulous people never go wrong. They scrupulously note down each letter and never seek to unravel the mystery of a sentence before it is completed. Nor would they dream of completing a single word for you. Unwilling to chance the smallest error, they will never take it upon themselves to provide the room that follows mush for mushroom, the ick that follows atom for atomic, or the nabal without which neither interminable nor abominable can exist. Such scrupulousness makes for laborious progress, but at least you avoid the misunderstandings in which impulsive visitors bog down when they neglect to verify their intuitions. Yet I understood the poetry of such mind games one day when, attempting to ask for my glasses, lunettes in French, I was asked instead what I wanted to do with the moon, which is lune. So The Diving Bell and the Butterfly, that was the title of his memoirs, and it's metaphorical, of course. So the butterfly, as you might imagine, represents the positive side of the locked-in syndrome that Bowlby was suffering. And that positive side is an extraordinary life of the mind that he describes. The hospital he was in was on the French seaside, and sometimes they would take him out on day trips on the beach, and he describes directing films set on the beaches in his mind, and he traveled in his mind. And he wrote this wonderful imagery, like the treetops foaming like surf against glass building fronts, wisps of cloud in the sky, nothing was missing except me. I was elsewhere. So he was the butterfly. The diving bell represented the oppressive side of his condition. And a diving bell is an ancient, pre-scuba diving technology. It was basically a bell-shaped enclosure that would trap air inside, and the diver would be inside as well, and they would just lower it down into the sea, and the differential pressure would keep the air in there for the diver to breathe. And in his memoirs, Bobby described this diving bell directly. He said, "The identity badge pinned to Sandrine's white tunic says speech therapist, but it should read guardian angel. When Sandrine knocks and pokes her small chipmunk face through the door, at once it sends all gloomy thoughts packing. The invisible and eternally imprisoning diving bell seems less oppressive." So I first came across Bobby's story in the 2007 film adaptation of his memoirs. And this was, it was actually a product of late night Netflix browsing, as you do. So I didn't know, I didn't know about the film in advance, and I didn't know what I was getting myself into. And about 10 minutes in, when it became really clear what the story was about, I almost noped out because it was just too nightmare fuel for me, the whole locked-in syndrome situation. But I kept going, and then it really stuck with me, obviously, because now I'm about to tell you all about a project that I've done based on this, which is what I really came away with was I just wanted to know what it would really be like to write a whole book using this really laborious and slow, painful method. So what I've done is I've built an app that simulates partner-assisted scanning, but this is partnerless partner-assisted scanning. Basically, the app interface replaces the partner. And I've still done the selection of letters with blinks, but I didn't go for the full fidelity with Bobby's experience and do it with one eye, because not all of us are as gifted in the winking department. So the piece of open source technology that makes all this possible is a library called Webgazer JAS. This is a project out of the Human-Computer Interaction Lab at Brown University, and it's still maintained by folks there, as well as other contributors from the open source community and a bunch of collaborators at Georgia Institute of Technology. And it's copyleft licensed under the GPL. And it's completely free, obviously. Anyone can use it. It uses the browser to do eye tracking using your webcam. And the real genius of it is that it's all in the client. So there's no server involved, no transmission of webcam images that would probably make people less likely to want to use something like this due to the security and privacy concerns. So now we're going to dive in a little bit, and I'll start by showing you a little bit of how Webgazer works and the APIs. So you load it in a script tag, and this is actually currently a limitation of the project. They're still working on porting to CommonJS modules or ES6 modules. It's in progress, but hasn't been completed. To start, just to look at the vanilla JavaScript before we get to React, we'll have this Webgazer object on the global window object, and you just set a gaze listener, a callback function, and that callback, when it gets called, will receive two arguments, a data object which will contain the coordinates of the predicted location of your gaze or the user's gaze, and then an elapsed timestamp. And then you just call begin. It's really simple. So integrating this with React is the next step, of course, and I'm actually going to kind of skip this part because Michael Jackson reminded you all about how script tags work this morning, so that's great. I don't have to do it. I'm actually loading two script tags in the project that are coming from Webgazer. One is the whole library, and then a second one is a script to do the algorithmic processing of the webcam images in a web worker. So if you haven't used web workers before, they're a mechanism where you can put some of your JavaScript in a separate thread in the browser to do laborious data processing and not bog down your UI and make it slower. And that's relatively critical in using this library, I would say. You don't have to put it in the web worker. They have ways of doing the regression, and that's actually the default, is to do the regression in the client on the images. But my experience is definitely that the web worker makes it a lot more accurate. So now that's one side of how to get this going, like how to actually load it up in a React app when we're not really used to using script tags in React that often. But the second question is, of course, more about how to integrate this thing that's stateful itself in with React components. And in this to answer this question, like the life cycle is the answer here. The life cycle is your friend. So we're going to start with a simple Webgazer component in React. So this will be a class, not a pure functional component, because we need to use the lifecycle methods. And we're just going to start with some really simple state. 0 blinks, because nothing's happening yet, and null for x and y coordinates. This will eventually be the x and y coordinate of your gaze location on the screen. So this is relative to the viewport. And in component did mount after the initial render, I'm just setting up a gaze listener again. And the only part of that that's different from what we saw in the vanilla JS is instead of console.logging what you get in the data, which is what I was doing before, we're going to set that in the component state. And now I'm hand waving the blinks part here. And I apologize for that. I did kind of try to put it into slides, but the truth here is that blink detection only came into the library in the last month, and it's not exposed in the public APIs yet. And so I did some pretty fantastic hacking to expose it for this project for myself. I haven't put in pull requests or anything yet. You certainly wouldn't want a pull request from the code that I did. I'm just waiting to see if they're going to integrate it into the public APIs. I think really what you would want, so what I've done is hacked a way to expose it in this data object that you get in the gaze listener callback. And I think probably what you want ultimately is a set blink listener callback. So yeah, this is wrong on a couple of levels, and we're going to hand wave it. And then finally, I'm just rendering the x and y position of your gaze, and just going to render a no blinks to start, and then a blinked at least once when the blinks get detected, or when one gets detected. So this is what this looks like, and this is a GIF because I tried to do in the tech check last night. This setup with the lighting is not really conducive to live demoing Webgazer. And the other thing I should note, so it's very sensitive to lighting, as you can imagine. It also doesn't work very well for people who wear glasses, so just as a note. So in this recording, obviously the null is at the beginning, and then the page loaded when I recorded this, and then it starts predicting where my gaze is and recognizes a blink when it happens. Now we missed one thing. We didn't clean up after ourselves. So you do want to clear the gaze listener after unmounting the component, and then calling end on Webgazer does some internal cleanup there. And then there's one more piece of the Webgazer API that's fun, and that's that you can show the predicted point of your gaze in real time as it's predicting with this show prediction points method. So we can just insert that before the call to begin and pass it true. And then the same thing, we'll want to pass it false when we're cleaning up. Otherwise, the dot stays on the page. So now you're going to see another GIF recording, and the gaze location is this big magenta circle. I made a custom build of the library to do this. It's not usually that big, but I wanted you to be able to see it. So there it is. And the other thing going on here is you can see that my cursor is moving, and I'm actually clicking as well when I made this recording. So this project that I'm telling you about is, I consider it a proof of concept, not an actual accessibility tool, because Webgazer does rely on cursor movements and clicks under the assumption, they use those under the assumption that you're typically looking at the cursor when you're moving it, which I think is a pretty good assumption. So they use that to train and calibrate, and since you can't basically make an accessible interface for doing that training, that's what makes this just a proof of concept. All right, so that's all about Webgazer. Now let's kind of sketch out what the app is going to look like. And so I've said that this is partnerless, partner-assisted scanning, and that we're replacing the partner with a web app. So the best place to start here, and what do we need, is to look at the partner's role in partner-assisted scanning. So the partner basically does three things. The first is that they display the frequency-ordered alphabet for reference. And this is what the equivalent English one would look like. The second part of their role is to loop through the letters. Now this can be done aloud and by pointing at the letters on the card. Two modalities at once is great. And then the final, third part of the partner's role is to obviously record the letters that are selected. So if we take those three parts, those three sub-roles, and map them out into UI components, it might look something like this. So in the right, upper right, we've got the whole alphabet reference. In the upper left, we've got a big letter showing you what the current letter is, and we also highlight it a little bit in the whole reference. And then at the bottom of the screen, we have an input where we're recording selected letters. So now that we've got a sketch, components on a screen, we can map those into React components. So let's call this app a class called scanner. And the letters in the frequency ordered alphabet are really kind of a constant here. You may want to build out an interface to switch between languages, of course, but even then, it's not going to, per language, that list is not going to change. So that kind of belongs in a default prop. The state that we're going to start with, at least, is the current letter and an array for the selected letters. And then we just get three components basically exactly aligning with those three boxes in the UI sketch. So the current letter, the frequency ordered alphabet, and the selected letters. So now let's get into more kind of code. So the first piece of functionality that we need to implement is looping through the letters. And as soon as you start doing any kind of a looping thing in an app, basically you're going to realize that there's three additional things that you need that we left off of Sketch, which is a bunch of buttons. Basically the minimum is start, pause, and reset. And so that means we need a little bit more state. So I've added a current index here because index is the easiest way to increment the looping, obviously, or increment the current letter by looping and pulling out the letter at the index that you're at. This actually means that we don't need the current letter in state anymore because it's derived from the current index and the list of letters, which is immutable as a prop. But I left it in there right now just for ease of understanding. And we still have the selected letters as an empty array to start. And then we've also added this started Boolean flag to help us track what state we're in, whether we've started, paused, et cetera. And then adding all those buttons. And each one of these has a click handler, start, pause, and reset. The first thing in the start method is just setting the first current letter and flipping that Boolean flag started to true. And then we set up an interval on every iteration, increment the current index and pull out a new current letter. And then there's obviously a bunch of logic here, which is why I did the little pseudocode thing, because we need to remember to reset back to 0 when we reach the end of the alphabet. In pause, we just clear that interval, and then we flip the Boolean flag for started back to false. And reset is the same, only we also reset all the other state. So this is what it looks like, pretty much. We've got the three components that aligned with our boxes on our UI sketch. We've got three buttons. And then there's another one that I've added here, and that's the letter selector. So this is where we integrate Webgazer for detecting blinks. And the way we're going to do this is 2 blinks when the same letter is active counts as selection. Now, this is going to be all in the lifecycle methods, as we've already seen with Webgazer. And we're not using any of those lifecycle methods in that scanner component at the moment. So we could just put all that in there. But that component's already getting pretty big with all the instance methods for the start and the pause and the reset. So I like putting this as another child component. But we're going to need a SelectLetter method in Scanner that we can pass down as a function, as a prop to that letter selector. And this it's pretty simple, is what you would expect. The most important thing it does, obviously, is give you, put the current letter into that array of selected letters at the end. And then it also resets the current index to 0 and your current letter if you're still keeping that around, even though it's derived. And so that's because once you select a letter, you start looping through the frequency ordered list again. So now the letter selector component. So in component did mount, we set up the Webgazer gaze listener, giving it a callback. All we really care about is the data. We don't really need the timestamp. And again, I'm hand-waving again, mostly because there's actually a lot of logic here. But I think you can probably see how, based on the data of the gaze location, or the data with the blink data, and the props, which let you know what the current letter is, because we'd passed that down from scanner, that's how you can detect that there are 2 blinks on the same letter. And when that's true, the passed-in SelectLetter function gets called. Component will receive props is responsible for handling the state, so of whether or not you're running the eye tracking. So we use that started Boolean flag, which we would also pass down from scanner as a prop, and either pause or resume Webgazer as necessary. And then clean up as usual. And then finally, we're not rendering anything in this component. This component is just here to handle all the lifecycle logic, and it's nice and encapsulated that way. So here's a GIF recording of what the actual prototype looks like. And yes, it is. So I don't know if it's probably, this one is a little small, sorry. But I blinked twice and you got an H. And now it looped, oh, sorry, I missed it. But it's going to go through again. And just pay attention to how the cursor doesn't ever leave the start button. That's the look ma no hands part of this demo. All right, so that's it pretty much for this proof of concept. So why did I start with this, right? I hope you've had that question in the back of your mind for a while. So this project really started for me, as I've told you, as an empathy exercise. I wanted to understand what it was like to communicate with this partner-assisted scanning method, and I definitely got that out of it. I encourage you to try the proof of concept. It takes a very calm, very zen frame of mind to sit there and spell something longer than like 3 letters, trust me. And so I started with this because I got more than just the empathy exercise out of this project. It really changed the way I think about one of the pieces of technology that's critical here, which is the webcam. So webcams, I feel like they occupy a pretty low time in public opinion these days. I mean, chat roulette was a thing not that long ago, and a mistake. I think it still exists, unfortunately. And even worse than that, webcams are totally seen as this vector for spying and hacking, and I've seen people at this conference who are disabling theirs by putting a sticker over it. I love this one where they just skip over the should you cover your webcam question and go right to how should you cover your webcam. So disabling these things is super common, and they just, people don't think about them as a piece of technology that could be leveraged in lots of cool ways. So I was really surprised to learn that of how webcams got started. So this is an image from the very first webcam. If you can, I think it's pretty obvious that it's an image of a coffee pot. And that's because a group of computer scientists at Cambridge in England, not Massachusetts, they had this coffee club, but some of the people in the building were several floors or staircases away from where the coffee pot was. And they didn't like it when they would go hike 4 flights of stairs and find that the coffee pot was empty. So these computer scientists, on their internal network that was actually pre-World Wide Web, set up a camera that would push still images of the coffee pot so that anyone that was on this network could look at a certain web page and, or maybe it wasn't a web page then, pre-World Wide Web, but they had somewhere to look and they could see whether or not the coffee pot was full or not. So basically, there's a contrast here, I think, between treadmills that started as something that people really only saw value in for punishment, and then today are being, people use them in their free time and love them, pay money to use them. And the webcams started with this really cool project to increase human efficiency and human coffee dynamic systems. And yet now today, they're kind of in the gutter of public opinion. So the point here for me is this point that technologies have these histories and contexts, but those histories and contexts are not definitive. And so we should avoid the trap of thinking that they are. And I would encourage you to always try to keep an open mind to every piece of technology that surrounds you, and feel free to use it beyond its intended purpose, or beyond whatever purposes public opinion tells you that it's good for or not good for. And I do have a slide here with references and resources. I would encourage you to just find the slide deck online, not, like, obviously you can't copy these down from here. And thank you. The prototype is at divingbell.io, so give it a try if you want.